Hello and welcome to Cadence Design Systems Fidelity Tutorial Tuesday, where we show you how to use a feature or demonstrate the technique in just a few minutes. Today, we're going to talk about the new assisted model assembly tool in Fidelity Pointwise. So in the past, the only option available to the users for assembling surfaces and quilts into models was the Assemble Models from the Create menu. Now, there's been a lot of improvements made to this tool over the past several releases. For example, we can now identify symmetry loops, or there are ways to cycle through different model loops, which will make things a lot easier. But there were still cases where the user had to take some additional steps before being able to assemble the model. One example is when the maximum allowed edge tolerance for model assembly was still not quite large enough to close lamina boundaries. Now, this maximum allowed edge tolerance I'm talking about is actually controlled by the model size, which means to fix these types of issues, the user had to kind of like go back and adjust the model size, which in some cases would require re-importing the CAD geometry with a larger model size. Another issue I can think of is when the user detects holes in the geometry or maybe some missing surfaces. And in these instances, the user would have to exit the model assembly, then manually create these patches to close these holes before re-attempting to assemble the model. And probably last, but certainly not least, would be cases where we would notice overlapping or duplicate surfaces, which again would require the user to exit model assembly, delete these surfaces, and then try to reassemble the models. So this is where assisted model assembly, or AMA, comes into play. The assisted model assembly is this new advanced tool that was introduced as part of Fidelity Pointwise version 2025.1. The AMA command provides diagnostic and repair tools for assessing and fixing common issues with model assembly. Now, there's a lot of features packed into AMA, which we're going to talk about, but in general, the workflow is as follows. We first bring all models, quilts, and surfaces into the assisted model assembly tool, and it's usually a good idea to first assemble everything using the default edge tolerance. After this first attempt, if there are any issues with the model, they will be classified and listed for the user to review. There are several repair tools available to the user, which can be leveraged depending on the type of issue. And by the way, after each repair operation, the model is reassembled and reanalyzed, so the list of issues will get updated. And if needed, the user can actually adjust some of the settings for issue classification. And typically, this process is complete once all the issues have been identified and repaired. Okay, I think the best way to learn how to leverage AMA for your meshing workflow will be to actually see it in action. So I would like to demonstrate this great new feature in Fidelity Pointwise by attempting to assemble a detailed CAD geometry. I have here the NASA high-lift CRM model for the full landing configuration. And this is actually the Onera model that was used as the test case 2.4 configuration for the fifth high-lift prediction workshop. So let me go ahead and import the step file. Since we already know the largest characteristic length of this model, I could actually manually set the desired model size during import. But I will let Pointwise automatically adjust this for me. So the CAD model is imported into Pointwise. If I go to File Properties, I can see that the model size is actually kept at its default value of 1000. As I mentioned earlier, the model size controls many of the tolerances used downstream. Particularly for model assembly, the default edge tolerance would be set to exactly 6 orders of magnitude smaller than the model size. And the maximum allowed edge tolerance for assembly would be an order of magnitude larger than that. So you see how these tolerances are related to the model size. So just keep this in mind as we go through model assembly for this geometry. I will now select all database entities and go to Create Assisted Model Assembly. When you enter the AMA command, you'll notice model boundaries are all colored differently depending on the type of issue detected. But before we actually get started, I will go ahead and assemble everything with the default edge tolerance. So I'm not going to change the edge tolerance. I'm just going to go ahead and click Assemble. And you can see most of the issues with the model have already been resolved, and we have these assembled boundaries grouped together. And by default, they're actually disabled to declutter the view, but you can enable or disable them. I can see that there are actually several issues with the model listed here under the issues frame. And more specifically, there are actually 34 free boundaries. So let's review these together. When you open up the free boundaries type in the issues list, you see there are some of them are classified as laminar loops, some classified as slit groups. And if I open up the laminar loops, you'll see we have actually 28 slit loops and 4 unspecified loops. So what are these? Let me explain. Slit loops are laminar loops that are characterized by two sharp corners, typically at the two ends, with an kind of like an opening or a small distance in the middle. You can think of them as like terms in the geometry, where the distance between the opposing boundaries is actually larger than the edge assembly tolerance. And slit groups are also just a collection of these smaller slit loops. But since they're connected to each other, Pointwise will classify them for you as slit groups. A very important piece of information about these slit groups or slit loops is the maximum distance detected for each of them. So these values, you can see they're actually reported here, and you can even sort these based on the maximum distance. And this is kind of like the maximum gap in the boundary. And you can notice that these distances are actually greater than the edge tolerance used up here, right? And so in many cases, these distances might even be greater than the maximum allowed edge tolerance for assembly. And these would be the cases where in the past you had to go back and increase the model size in order to be able to assemble these boundaries. But now in AMA, as you'll see in a second, you have a repair option called stitch, which will actually locally increase the edge tolerance to assemble these slit loops for you. So let me go ahead and select all slit loops and do stitch. And you can see those issues are gone now. Remember, every time you perform any of these repair operations, AMA will reassemble the models and the list of issues will get updated automatically. So let me go ahead and do the same for these slit groups. Again, select them and use the stitch command, and you see I got rid of all of those slit boundaries. Now, it seems like I still have 3 laminar loops actually that are left. And these are classified as unspecified loops. So generally speaking, these unspecified loops could be some maybe holes in the geometry, maybe some missing surfaces, and that is why for this type of issue, you get the perimeter of the laminar loop, which is kind of like an indicator of the size of that boundary or the size of that hole or size of that missing surface. Now, if these laminar loops were actually holes in the geometry, then you have the option to fill them up. Note that both fill and patch commands are basically used for creating new surfaces to close the holes. Now, the fill is the automated mode, sort of like a one-click approach for surface creation. But you can always try that repair option first, and if that didn't give you the desired outcome, you can go back and use patch instead, which will actually take you as you can see, to this patch creation frame with a lot more control over the creation of that surface patch. Now, let me cancel out of this. What's great here is that I can actually select all of these three lamina loops, and now I can use the cycle selection view tool from the toolbar. And this allows me, as you can see, to zoom in on each of these boundaries to better examine them. Now, these lamina loops don't really look like a hole or missing surface issue to me. And these are kind of like very typical of CAD geometries with largely varied tolerances around the geometry. And so in other words, these lamina loops are actually some slit loops, but the maximum distance or gap in the slit is actually too large that they're not classified as a slit loop. And so if I open up the advanced frame, you'll see that we have this the slit maximum distance, and that is by default is set to an order of magnitude larger than the default edge tolerance. And this value you see here, 0.01, is in fact the maximum allowed edge tolerance for model assembly based on a model size of 1000. You remember I talked to you about this. As I mentioned in the past, you would have to go out of this command, increase the model size, and come back here to increase the edge tolerance before you could assemble these. So let me increase this slit maximum distance to, let's say, 0.1, and I will click Analyze so that AMA will reanalyze the geometry. And you see AMA goes back and reanalyzes all the model issues, and we can now see that those lamina loops are now reclassified as slit loops. In fact, if we look at the maximum distances reported here, we can clearly see the issue. So for these slit loops, the maximum distance is much larger, which means I would probably need to go back and increase the model size to at least 2500 or maybe 3000 to be able to increase the edge tolerance beyond the max distance value to be able to close these slits. But the great thing with assisted model assembly is that we don't have to do any of that. I can simply select all of these slit loops and stitch them, which will locally increase the assembly tolerance needed to close these up. And here we go. We were able to get rid of all of the free boundaries in the geometry, and our model is now closed and watertight, maybe even too watertight. I mean, you can see that the model is completely closed, and this is actually a half symmetry model, but it appears that we have a closeout surface here on the symmetry plane. Let me open up the display frame and reduce the model transparency, and you'll see what I'm talking about. So the CAD geometry actually comes with a closeout surface, which makes this a fully watertight model. But you know that we don't need to mesh this part of the geometry, right? This is on the symmetry plane, and we don't need this part of the geometry to be meshed. Now, under the repair frame, you see we have this option called delete quilts. And this is particularly useful when we have duplicated surfaces or overlapping quilts, and we need to, for example, get rid of some of them. Now, in this example, I'm going to use this same option to delete the closeout surface, which is unnecessary. And you see, as soon as I did that, assisted model assembly again reanalyzed the model, and it's now detecting a new free boundary for me, and this is of type symmetry loop, which means that we have a laminar loop or an opening in the model, but the entire loop is actually, it happens to be on the same plane, in this case, the symmetry plane. So it is detected as a symmetry loop. And these laminal loops are not really an issue with the geometry, as you know, which is why they're colored in green. So Pointwise is basically telling us that it has detected symmetry in the geometry. So we are okay. And before I wrap up, I want to show you another cool feature. And when you're inside the assisted model assembly menu, you actually have undo and redo operations available to you, which are really useful because you can actually undo any of these repair operations, for example, such as stitch, fill, patch, or delete quilts. And right here, if I click on undo from the toolbar, or simply do Control Z, I will undo the last operation, which was deleting that closeout quilt, right? And I can now hit Control Y or redo to repeat the last operation and delete the quilts. So this is again very, very useful. And we're now done with this command, and I can press OK to exit out of AMA. Okay, so this geometry is now ready for meshing. If we needed any quilting, I could take the model into assisted quilt assembly to take care of those, or I can move right ahead and bring the model into automatic surface mesh tool to start generating my mesh. So thank you for watching. If you like this video, be sure to click the thumbs up button to subscribe to our channel for more videos like this. If you have any questions or suggestions for future videos, please drop us a line down below or connect with us on LinkedIn, which is linked in the description. Thank you all and have a pleasant Tuesday.